Now let us move to the next topic of discussion, which is what one's programming approach should be. We'll discuss about pseudocodes, flowcharts, and why one should use them to become a better programmer, especially if they're a beginner. A pseudocode is basically an artificial code. It does not follow the syntax of any programming language. It is written in plain English. Now, how is it useful? It helps us plan the entire logic of the program before writing the code. By writing a pseudocode, one is specifically describing the tasks that the program should do in order to fulfill the objective at hand. So there are a few basic rules to keep in mind when writing a pseudocode. The first rule is that we have to write one statement or instruction per line. We have to capitalize important keywords, words that specify instructions like read, compute, initialize, print, etc. These keywords are important because when translating a pseudocode into a real code, these keywords help us in choosing the right commands. Finally, when using multi-line structures like if, else, for, we have to indent the statements written inside these structures and also terminate these structures by writing end statement. Here is an example of how a pseudocode is written. So we're writing a pseudocode to classify a number as odd or even from an array of numbers. So what we want the code to do is first create an array, and for each element inside the array, check if that element is even or odd, and then display respective statement saying the number is even or the number is odd. So that is what we want the code to do. Now let us go through the pseudocode for the same. Any pseudocode starts with the begin keyword and ends with the end keyword. We first initialize an array called an array. So initializing basically means creating an array. So we need to create this array before we proceed into the code. Then for each element inside an array, we print the element for reference and check if the element is divisible by 2. If it is divisible by 2, we print the number is even. Otherwise, we print that the number is odd. And then we close the if structure by writing end if. We close the for structure by writing end for, and we terminate the entire pseudocode by writing end. So a pseudocode, if we look at it, it's essentially verbal instructions. But when we write these instructions in such a format, the logic is clear, right? And these instructions can be easily converted into the real code. So what we can see on the right is the actual code. So what we've done here is that we've essentially converted these verbal instructions into a form that Matlab can understand. So the clear, close, CLC statements form a default part of any code. So we don't have to necessarily mention it inside a pseudocode because they're not part of the logic. So the actual logic starts here. So as written in the pseudocode, so we first initialize an array, which is essentially creating the n array. Now for each element of n array, we have to print the element, check if the element is divisible by 2, and then print respective statements, right? And that is what is being accomplished by using a for loop, right? So n is a loop variable, and n is going to take each element of n array one by one, starting from the first value, right? So in the first iteration, n is going to take the first value of n array, which is 1. In the second iteration, it's going to take the second value, which is 5, and so on. And at each iteration, we want to check if that number is divisible by 2, right? To do this, we use the modulus operator or the mod function in Matlab. This function returns the remainder of any division operation. So if I divide n, which is 1 in the first iteration, by 2, I'm going to get a remainder of 1. And this is a double equal to symbol. which is basically an equivalent operator. If the number is divisible by 2, then its remainder is going to be 0, and this operation is going to be evaluated true. If it is true, then we know that the control goes inside the if branch, and this statement is executed, which is going to print the number is even. And if this statement is false, which means if the remainder is not 0, then the control is not going to go inside the if branch, it's going to go inside the else branch. And this statement is going to be executed, which is going to print number is odd in the command window. This happens for all values of n array one by one. And this for loop, since there are 10 elements inside n array, this for loop is going to run 10 times. And when we're using user-defined functions in our code, then we have to write a separate pseudocode for the main code as well as the function. In the main code, the function call statement can be represented by using the call keyword followed by the function name followed by the arguments to be passed within the parentheses. And in the pseudocode for the function definition, we start with the function keyword followed by the function name, and in the next line we mention the values that are going to be passed into this function and then implement the same logic as seen before. So for each element of the array, we first print the element and check if it is divisible by 2. If it is divisible by 2, then the number is even, or else the number is odd. And then we end the structure for structure. And we also have to mention if we're passing anything back to the main code. Since we're not passing anything back to the main code, we can write nothing. And we can end the function definition pseudocode. Now coming to flowchart. A flowchart is a graphical representation of an algorithm. It uses a set of symbols or shapes to visually represent the flow of control inside a code. And compared to a pseudocode, a flowchart is more useful in creating coding logic and communicating it to others. But on the other hand, it is more time consuming, and when we're dealing with a big code, creating flowchart for that code might easily become cumbersome. And creating a flowchart helps in debugging as well. You can use flowchart to find loopholes in the coding logic and correct them. And this slide shows the basic symbols used in flowcharting. The line with an arrow is called a flow line, and it represents the direction of control flow inside a code. The oval shape indicates start or stop. It represents the beginning or end of a code. The parallelogram indicates an input or output operation, like reading input from the user, printing output on the screen, etc. A rectangle represents a process or an operation. So any operation except input, output, be it assignment operation or arithmetic operation. So these are written inside a rectangle. A diamond represents a decision point where the code has to make a choice whether it has to run a certain part of the code or not. This is used for branching. A circle is used as a connector. When the flowchart goes really big, sometimes across multiple pages, connectors are used to maintain the connectivity through the flowchart. And finally, this shape, a rectangle with two parallel lines, represents a predefined process or a function. Right? This is what is used to represent the user-defined functions inside a code. Actually, these symbols might look familiar to you. If you might remember, we've already used these symbols to create flowchart to study the control flow inside if-else and for structures. Let us go to that slide where we studied the if structure by using a flowchart. So this is the flowchart I was talking about. You can see here that we have used oval shape to represent start and the stop of the control, the flow lines to represent the flow of our control, diamond shape as a decision point, and rectangle for basic operations. Now I hope you can understand how by using a flowchart one can easily comprehend the working of a code or a part of a code. Please feel free to check out the flowchart for other structures as well. Let us go back to the flowchart slide. Here is another example of a flowchart. This is the same code as seen before. This is to check if a number is odd or even from an array of numbers. So we use an oval shape to represent start. We initialize the n array. So here the implementation of the for loop is going to be slightly different. So instead of the loop variable assuming the elements of n array directly one by one, so the loop variable is going to assume values from 1 to the length of n array incrementally, right? So which is first it's going to assume 1 and then 2 and then 3 and then 4 until the length of n array, right? And for each value it assumes we first check the condition. We check if I is less than or equal to the length of n array, right? So in the first iteration I is going to be initialized to 1. I will be less than or equal to length of n array, which is, let's say in our case it's 10. So since this condition is true, the control is going to flow to the to this part of the flowchart. So here I've used a connector because this is the end of the page, and generally we don't propagate flowchart towards the right. So it is best to put a connector here and then resume the flow of control from the right hand side. So when this condition is true, the control basically comes to this connector, and then from this connector to this print statement. So what happens is when the condition is true, first we print the n array of I. So I is 1 in the first iteration. So in the first iteration we're basically printing the first element of n array, and then we check if that first element is divisible by 2. If it is divisible, then we print the number as even. If it is not, we print the number as odd. And then at the end we increment the value of I by 1, right? So after this operation the value of I is going to be 2, and we've used another connector here, right? And the control goes back to the condition where again the condition is checked. Now the value of I is 2. Is 2 less than or equal to length of n array? It's 10. Yes. So again the condition is true. The control flows to this part of the code where we print n array of 2, which is the second element of n array, and then we check if that second element is divisible by 2. If true, number is even. If false, number is odd, and then we increment the value of I by 1 again. So this loop keeps running until I is greater than the length of n array, right? So let's say the length of n array is 10, and after the 10th iteration is done, I is going to be 10 plus 1, which is 11, and the condition and the control flows to this decision point where again the condition is checked, and this time this condition is not going to be true because I is greater than the length of n array. So this is when the loop stops. So this is another implementation of the for loop, right? Instead of the loop variable assuming the elements of the n array directly, so we initialize the loop variable from 1 to the length of n array with an increment of 1, right? So we can actually use the loop variable as an index and call out elements of n array one by one in a sequential manner. Now let us move to the next slide. So this slide shows the code for the same flowchart that we saw on the previous slide. We've created the n array, and here if you see, this is where my for loop starts. I is the loop variable, and this time rather than directly saying I is equal to n array, so we've written I is equal to 1 to length of n array. So this is also going to be an array starting from 1 and ending at 10, which is the length of n array, and the increment is going to be 1. So that is the default increment when we're using a colon operator. So the loop variable, which is I, it assumes the value 1 in the first iteration, right? And then an array of 1, which is the first element, is printed, and we divide the first element of an array by 2 and check if the remainder is equivalent to 0 using the equality operator. And if it is, we print the number as even. If it is not, we print the number as odd. This happens until I reaches a value of 10, and so the for loop in total runs 10 iterations. Now, when we're using function inside a code, so this is how the flowchart can be created for the main code as well as the function code. So we initialize an array, we call the function, and when we're calling the function, we pass an array as the argument, right? And then the function is going to take care of the rest, and then we end the main code, right? And this is how the flowchart for a user-defined function is written. So we first use the oval shape, which represents the start of control. So inside the function, and we mention the function name inside this oval shape with the argument that we're passing, which is an array. And then we follow the same logic, which is first initialize I is equal to 1, check if that I is less than or equal to length of an array. If it is true, we print an array of I, and then check if it is divisible by 2. Again, print number is even if it is, and if it is not, print number is odd, and then increment the value of I by 1, right? And this loop goes on repeating until the value of I is more than the length of an array, and that is when the condition fails. That is when the function ends, right? So this oval shape here marks the start of the function, and this oval shape here marks the end of the function. And since we are not returning anything to the main code, there is no requirement to return anything to the main code. So we've written nothing here. In case the function is, let's say, adding two numbers and returning the sum to the main code, in that case, we have to have a return variable. And we also have to place a variable to store the result that the function is going to return.